So in this problem, we have a mixing problem where, in this case, it's Conway. She's looking to mix two buckets, essentially, of secret solution to get the ideal percent, which is 30%. So it says that the ideal percent is 30% to be effective. So our final one, we need to have 30% of the secret formula. We know that in one bucket we have 40 milliliters of the 75% solution. So 75% of what's in here is the secret solution, and we have 40 milliliters of it. And then we have this other bucket with 20%, so it's not quite as high of a dose, and we have no idea how many milliliters we need to add into the 75. So we need to dilute the 75% down so we can get to our 30% by adding some of the 20%. So this formula we want to use is, well, 30% is actually 3 out of 10. And if we're thinking about the total amount of liquid, which is our denominator, so our total liquid that we're going to use, well, we're going to have 40 milliliters from our 75% solution, and then we're going to add X milliliters of the 20. So our total amount of liquid would be 40 plus X. Our numerator is going to be the percent, or the amount rather, of the secret formula. So in our 75%, we know we can find the total amount of that is 0.75 times 40. And then from our 20% bucket, it would be 0.2 times X, the number of milliliters we'd be adding into this. So if I'm going to clean up this is still 3 out of 10. 0.75 times 40, that's going to be 30, plus 0.2x over 40 plus x. Now if we cross multiply, what we end up with is 3 times 40 plus x equals 10 times 30 plus 0.2x. So if I were to distribute the 30 and the 10, we end up getting 120 plus 3x equals, if we distribute that 10, we'd have 300 plus 2x. So, and then by subtracting 2x to both sides, subtracting 120 to both sides, we get x to be 180 milliliters.